Heisenberg. The name itself sounds like a mystery, a puzzle wrapped in an enigma. But who was the man behind the legendary uncertainty principle? How did one mind so profoundly reshape our understanding of the universe? Today, we journey into the life of Werner Heisenberg, a titan of physics whose story is as complex and fascinating as the quantum world he helped uncover. Born in Würzburg, Germany, in 1901, Werner Karl Heisenberg showed a prodigious talent for mathematics and physics from a very young age. He wasn't just a bookworm. He was a deep thinker, constantly questioning the world around him. His academic journey led him to the University of Munich, where he studied under the great Arnold Sommerfeld. This was a golden era for physics, a time when the classical laws of Newton were beginning to crumble under the weight of new, strange discoveries at the atomic level. And a young, brilliant Heisenberg was about to step right into the center of this scientific revolution. He was destined to become one of the founding fathers of a completely new field, quantum mechanics. So, what exactly is quantum mechanics? Put simply, it's the science of the very, very small, the world of atoms, electrons, and photons. Before quantum mechanics, we thought we could about a particle its exact position, its exact speed, all at once. But Heisenberg and his colleagues discovered that this subatomic realm plays by a completely different set of rules. It's a world of probabilities, not certainties. A world where particles can be in multiple places at once, where observation itself changes the outcome. It's weird, it's as counterintuitive, and it asks the fundamental reality of our universe. In 1927, at the astonishingly young age of 25, Heisenberg published his most famous contribution to science, the uncertainty principle. This isn't just some abstract scientific idea. It has a fundamental limit on what we can know about nature. The principle states that there's a trade-off. The more precisely you know a particle's position, the less precisely you can know its momentum, and vice versa. Think of it like trying to measure a moving car. To pinpoint its exact location, you need a snapshot, a flash of light. But that flash gives the car a tiny push, changing its speed, its momentum, in a way you can't predict. In our everyday world, this effect is negligible. But for a tiny electron, the act of observing it fundamentally changes it. This wasn't a failure of our measuring instruments. It was a deep, built-in property of the universe itself. The impact was seismic. It sent shockwaves through not just physics, but philosophy, challenging the very idea of an objective, predictable reality. For this monumental breakthrough, for the creation of quantum mechanics, Werner Heisenberg was awarded the Nobel Prize in Physics in 1932. He was just 31 years old. He stood at the pinnacle of the scientific world, a genius recognized by his peers for forever changing how we see the cosmos. But as his scientific star rose, dark clouds were gathering over his homeland, and the world was heading towards its darkest hour. World War II. Heisenberg decided to stay in his country. Why? Some believe it was a deep patriotism and love for the country and its culture. He felt a duty to protect German science and help rebuild it after the war he knew was coming. Before the outbreak of the Second World War, in 1938, an Austrian physicist named Otto Frisch made a groundbreaking discovery related to the structure of the atomic nucleus. While working in a laboratory in Sweden, Frisch demonstrated that the nucleus of an atom could be split in a process that later became known as nuclear fission. This discovery marked a turning point in modern physics and fundamentally changed humanity's understanding of energy. Through his experiments, Frisch realized that when an atomic nucleus is split, an extraordinarily large amount of energy is released. Even more importantly, he observed that if this process could be sustained as a chain reaction, each fission event would trigger additional fissions. As a result, the amount of released energy would increase exponentially, producing an immense and powerful source of energy unlike anything previously known. Frisch published his findings in scientific journals, and his work quickly attracted the attention of leading physicists of the time. Among them was Werner Heisenberg, one of the most influential figures in theoretical physics. Heisenberg recognized the potential of nuclear fission and suggested that this new energy source could be used for peaceful purposes, particularly for the production of nuclear energy. He believed that by constructing nuclear reactors, humanity could benefit from this energy in areas such as industry, technology, and economic development. However, the political and military context of the late 1930s heavily influenced how this discovery was interpreted. In Nazi Germany, Frisch's findings became part of what was known as the German uranium project. Some German scientists and officials viewed nuclear fission primarily as a means to develop a nuclear weapon. As a result, research efforts increasingly shifted toward military applications. When Heisenberg was invited to participate in this project as a leading scientist, he continued to argue in favor of nuclear energy production rather than weapon development. He was saying that building a nuclear weapon is technically very difficult and full of uncertainties, and that it would be better to focus instead on the controlled use of nuclear energy, such as reactors and power plants. According to several historical interpretations, Heisenberg's stance reflected his desire to prevent nuclear science from being used solely for destructive purposes. And after war, he dedicated himself to rebuilding German science and became a powerful voice for the peaceful use of nuclear energy. He played an important role in founding the Max Planck Institute for Physics and served as its director. He firmly believed that the incredible power unlocked by his generation of physicists should be used to build and heal, not to destroy. He remained a prominent public figure in Germany until his death in 1976, a respected. So what is Heisenberg's legacy today? It's all around us. The quantum mechanics he pioneered is the bedrock of modern technology. Without it, we wouldn't have computers, smartphones, lasers, or MRI machines. Every time you use a device with a semiconductor chip, you are benefiting from the strange, probabilistic world that Heisenberg helped to reveal. His uncertainty principle continues to inspire and challenge us, reminding us that there are fundamental limits to our knowledge and that the universe is far more mysterious and wonderful than we can ever fully grasp. Werner Heisenberg's life shows us that science is not just about equations and experiments. It's a deeply human endeavor, filled with brilliance, friendship, conflict, and the enduring quest to understand our place in the cosmos. His story is a powerful reminder of the responsibility that comes with great knowledge. Werner Heisenberg shows us that science is not just about numbers and formulas. It is also about the choices we make and the responsibility that comes with knowledge. He believed that science should serve peace, progress, and the improvement of human life, not destruction. His message is simple but profound. The true power of science is revealed when it is guided by ethics. Werner Heisenberg remained active in science and education until his final days. His legacy goes beyond formulas and theories. He taught us that science gains meaning when guided by responsibility and conscience. Every time we use modern technology or explore the mysteries of the universe, Heisenberg's influence is still with us. Let's be inspired by his message. Use science not just for power, but to build a better world. If you enjoyed this video and want to learn more about great scientists and exciting discoveries, click the subscribe button and join our channel so you never miss a video. See you in the next one.